Hi everyone. In this video we're going to be discussing 2012 AP Free Response question number 5. Now this question was on the AB portion as well as the BC portion. This was a question that students struggled on in the AB exam. They actually only ended up averaging between 2 to 3 points on this question. The fact that this is worth 9 points lets us know that this question was definitely difficult. So what we're going to do is we're just going to go ahead and read the question and kind of answer each part, A, B, and C. It says the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. The fact that they gave you a coordinate, you have to jot that down. And the fact that at time t equals 0, that's what we call an initial coordinate. It says if B of t is the weight of the bird in grams at time t days after it's first weighed, then dB over dt. Now, I'm also going to notice that this right here is the same thing as saying y prime. This is a derivative, which lets us find slope, which lets us find tangent lines, which lets us find the rate at something is changing. Then it says 1 over 5, parentheses, 100 minus b. Then it says let y equal b of t be the solution to the differential equation above with the initial condition b of 0 equals 20, which we already have down, so we don't have to kind of question this because we already know what it is. So part A says, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. Well, the fact that they want to know, is a bird gaining weight faster? Faster is like a rate. Is it increasing? Is it decreasing? Well, in calculus, we said that's the first derivative. Luckily, we already have the first derivative, so we don't have to find it. So when we have the first derivative, what we're going to just do is we're going to plug in 40 and we're going to plug in 70 into that equation because B represents the weight. So when we go ahead and plug it in, we're going to get dB over dt equals to 1/5 100 minus our first one, which is 40, which is going to simplify to give me 60 over 5, which gives me 12. And then the next one is going to be dB over dt is equal to 1/5 100 minus 70, which is going to be 30 over 5, which ends up giving me 6. So look at the two numbers. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Well, I would say 12 because that's a bigger number. That means it's increasing a lot faster. So that means that when they explain your reasoning, you get a point for showing this work. Now your next point is just explain what you just found. It gains weight faster when it weighs 40 grams. And if you're able to explain that in a sentence, then that right there gives you another point. So this question was worth 2 points. Just you by plugging in 40 and 70 into the equation determining the rates, and the fact that you're able to distinguish that the fact that when it weighs 40 grams, it's gaining weight faster. Then part B. Part B is saying find d2b over dt squared. And then it says use d squared b over d2 squared to explain why the graph of b cannot resemble the following graph. Now, when students saw this question, they probably got confused because they don't, in calculus you really don't work with a problem just like this. But you have to remember, what is the big difference between dB over dt and d squared b over d2 squared? All this is saying is find the second derivative. So what they want us to do is just go ahead and find your second derivative of the first equation. So what I'm going to first do is, for part B, I'm going to distribute that 1/5 so that I can get 1/5 times 100, which is going to be 20, minus 1/5 b. And they want me to find my second derivative. So I'm going to go, okay, well, second derivative of this, so derivative of 20 is just 0. Derivative of minus 1/5 b is just going to be negative 1/5. But you have to remember, all of this is in respect to time. And the fact that this is not time lets me know that I have to do dB over dt. And this kind of goes back to when you were working in calculus and anytime you had to find a derivative of something other than x, you had to add dx over d of that letter over dx. This is the same thing. The fact that they want me to find a derivative of b, but it's not t, I have to put dB over dt once I find that derivative. But then what is dB over t? Don't we have that? Yeah, that's right there. So what you're going to do is you're going to plug in that equation, dB over dt, back into this equation, which is negative 1/5 times 1/5, 100 minus b, and just distribute it out. So you get negative 1 over 25, 100 minus b. And this is my second derivative. So if you're able to find that, that right there is going to give you 1 point. But now the next point is, well, explain why the graph of b cannot resemble the following graph. Why can't this resemble that equation or original equation? And then for this question, students probably didn't answer this because it was tricky. But all you have to ask yourself is, what did you just find? Well, we just found second derivative. What does second derivative help us find? And then your answer should be concavity. Second derivative always helps us find concavity. Well, look at this. Negative 1 over 25 of 100 minus b. Well, let's say we were to equal to that 0 to find the critical numbers. I don't really have to focus on this number because it's just a constant. I'm going to focus on 100 minus b equal to 0. I'm going to solve it. I'm going to get b is equal to 100. So concavity is going to change when it's left of 100, maybe right of 100. Who knows? But 100 is our critical number. So back in calculus, you would always put the number on the number line, check points left, check points right. Now, if we check a point, let's say, I don't know, let's pick 20, just because that number was given to us. If we plug 20 in there, we're going to get concave down. When we plug 20 into here, 100 minus 20 is 80. 80 times negative 1 over 25 is going to give us concave down. We plug a number bigger than this, so let's say 120 is going to be 100 minus 120, which is negative 20, and negative 20 times a negative is going to be a positive, so that's concave up. So that means that anything less than 100 is going to be concave down. But look at your graph. If this is the original function, the fact that this is going up means it's concave up. But what is this saying between 0 to 100? This has to be concave down. So then what this means is this graph doesn't really resemble the same graph because a portion of it is concave up and it's telling us that it should be concave down. So your reasoning would be the graph of b is concave down when b is less than 100. And that's what we found right there, right? B is less than 100. A portion of the given graph is concave up. And it doesn't have to be verbatim what I just wrote. All you have to be able to say is that you found your second derivative and you said that it was concave down for anything less than 100 of the weight. But your graph is saying that it's concave up. So because of that, we know that this is not true at all. And for that reason, that's where you'll get your extra point. Okay? So when you see a question and you see d squared over d squared b over d2 squared, this just means second derivative. So just go ahead and find your second derivative of this. But any letter that is not t, you have to remember that you have to add d of that letter over dt. So I found my derivative of this, so because it was b, I had to add db over dt. Well, what is db over dt? That's your first derivative, so go ahead and plug that back into that, substitute it, and work it out, and you're going to get that equation. Okay? So now we're going to move on to part C. Now, part C is always going to be worth the most points when it comes to a question like this. Anytime you find differential equations, they're going to ask you to find a particular solution. So that just means we're going to integrate. So I'm going to write dB over dt is equal to 1/5 100 minus b. Well, when we integrate this, you have to remember, I need anything that has a b on the left side, anything that has a t on the right side. So I'm going to first multiply this dt to the other side. And hopefully you guys agree, but this is going to be dB is equal to 100, 1/5 100 minus b dt. Now I also don't like this number, this 100 minus b here. And that's because this is a dt, but this is a b, so where should I move this 100 minus b? Hopefully to the other side to join that dB. So this is now going to become dB over 100 minus b is equal to 1/5 dt. Now, this is perfect for what we were about to do. The fact that the left side has a whole bunch of b's and the right side has t's and a number, which is fine, I just separated it correctly. And if the fact that I'm able to separate this, I gain a point. So now your next step is, you have to find the antiderivative of this. Well, I can never have an expression on the bottom. So I know that that's going to be u is equal to 100 minus b. That's always going to be a u substitution because I can never have an expression on the bottom. So when Find my derivative of this. Du over db is equal to derivative of 100 is 0. Derivative of negative b is negative 1. Solve for db. This is going to equal to du over negative 1. And all I did was just technically put this over 1 and just swap these two. Now I'm going to plug that back in. And that's going to give me 1 over, and I'm taking this db to the side, du over negative 1 is equal to, I'm going to just copy down the right side, 1/5 dt. Well, when I integrate the left side, you have to remember this negative 1 is going to come to the outside, and anytime you have the integral of 1 over u, that's always going to be ln absolute value. So this is going to become negative 1 ln absolute value of u is equal to, and now integrate the right side. Well, this is just numbers, so how do you find the derivative of a number in respect to that letter? Hopefully you agree that's going to be 1/5 t. Now, your next step is the fact that you have a u. You cannot have that. So you have to plug in what your equation was. Well, my equation was 100 minus b. So I'm going to plug that back in. Negative ln absolute value, don't lose them, equals to 1/5 t. And the reason why you can't lose your absolute value is because you can never have a negative in the inside when it comes to ln. And the fact that we just integrated this, you have to keep the absolute values. Now, since I'm done, what I'm going to do is this. I'm going to find this c. I integrated both sides perfectly, and by the way, each integration between the left and the right side is 2 points. And the fact that I was able to add this c gives me another point. But I'm not done yet because they're trying to ask you for a particular solution. And you have to remember, a particular solution helps you find c. Well, at what point do they want me to find a particular solution for? The point that we wrote down in the beginning, which was 0, 20. So what you're going to do is you're going to plug in 0 and 20 into your equation, which is going to be negative ln 100 minus 20 equals to 1/5 times 0 plus c. And when you work it out, you're going to get negative ln absolute value of 80, which you can lose now because you know 80 is a positive number, is equal to c. And this is your c. And if you're able to find that, then that's going to let us know. But remember, particular solution is not just finding c, it's taking this c and plugging it into here. So then your next step is rewriting it so it's negative ln absolute value of 100 minus b equals to 1/5 t minus ln of 80. And if you're able to do that, you gain yourself 1 point. And all we're missing is one more point to complete this question. And this last point is always going to be solving for this b, solving for that variable. Now you have to ask yourself, okay, well, I don't really want this ln there. I don't want this negative there. I want to get ln by itself so I can get b by itself. So I'm going to first divide by negative 1, which means divide this by negative 1, which means divide this by negative 1. And you're going to end up getting ln absolute value of 100 minus b is equal to negative 1/5 t plus ln of 80. Now your next step is to get rid of this ln. Well, think about it. In precalculus and algebra, how do you get rid of an ln? Well, hopefully you're saying that in order to get rid of an ln, I have to put e to both sides, which means all of this is going to be e raised to that expression. Now e and the ln are going to cancel out, which is going to leave me with 100 minus b absolute value is equal to e to negative 1/5 t plus ln of 80. Now there's something that you have to be careful about. Anytime you see e and you have that being added or subtracted on the exponent, you have to remember, you have to always separate this so that this portion right here becomes e to the negative 1/5 t times e to the ln of 80. And the reason why you do that, and the reason why it's multiplication, is, think about it. I'm going to go to the side, a little bit of side work. Let's say I had x to the 4 plus y. Wouldn't you agree that this technically can be written as x to the 4 times x to the y? And the fact that I'm multiplying bases, what do I do with the exponents? If I'm multiplying the same bases, I have to add the exponents, which leaves me here. Which is why I'm always going to separate this with a multiplication symbol. And you don't actually have to show this work. You have to just understand that anytime you see you raise e, this is going to become a multiplication ln 80 every single time. So then your next step is, okay, well, what happens to e and ln 80? Cancels out. So this becomes absolute value 100 minus b is equal to e to the negative 1/5 t times 80. Well, where should I put that 80? In the front. Now, the last step, they always want you to assume that b is going to be a positive number. So they want you to just drop the absolute values and solve for b. Which means that if I subtract this 100, I'm going to bring it over. which leaves me with negative b is equal to 80 e to negative 150 minus 100. And my last step is I have to get rid of this negative. Well, how do I get rid of it? Divide by negative 1, divide by negative 1, divide by negative 1. And I'm going to get b is equal to negative 80 e to negative 150 plus 100. And if I'm able to do that, I get myself my last point. And hopefully 9 out of 9 points right. But if you notice, getting b by itself is only worth 1 point. So if you're not able to get b by itself, you'll at least be able to get 8 out of 9 points, which is hopefully going to be a passing score. So how do we get this alone? Just going over it one more time. Anytime you have a question that requires you to integrate both sides, you want to get everything that has a b to the left side and get this dt to the right side. Then from there, divide the 100 minus b so you can put it on the bottom so it's on the left side, and everything should match up. db have nothing but b's. Numbers with the other variable. Then whenever you have an expression on the bottom, you know that's going to be a u substitution. So go ahead and set this equal to u, and then plug in back in u, and just work it out. And anytime you have 1 over u, you have to remember that it's going to be ln absolute value of u. Now the last thing, when you integrate both sides and you plug u back in, you have to make sure you add a c. And the reason why you add a c is because in calculus you're always supposed to add a c since we don't know what this is. But we do know what it is if they give us a coordinate, and that's called a particular solution. So we're going to plug in 0 and 20 into the expression and solve for c. And then once you find the c, you're not done because you have to plug this back in. And the last step on the AP calculus problem is they're going to ask you to solve for this variable inside of ln, which is b. So get it alone by putting e to both sides. And then remember, if you have e and your exponent is things being added or subtracted, that really means it's being multiplied or divided. Addition means multiplication, subtraction would mean division, but it's always going to be addition when it comes to a problem like this. Okay? So hopefully you're able to do this. Hopefully this helped. And if you enjoyed this video, let me know. And thank you for watching.